This lesson, we're going to be looking at circle theorems. And the first lesson of this topic, we're going to be looking at angles at the circumference of a circle. So the first circle theorem we're going to look at, the full definition, or the full proof is the angle at the center of a circle is twice the angle at the circumference when they are both subtended by the same arc. Now that's a bit of a mouthful, and you don't need to actually remember this definition, but you do need to use how to use the rule. So first of all, let's actually show you what this rule means. So first of all, we're talking about an angle at the center of a circle. Okay, so if I have the center of my circle, and I have two lines going out from that center of a circle, I have an angle between those two lines, okay? And then if I have a point somewhere else on the circle, somewhere else on the circumference of the circle, and I draw two lines from that point, from the edge of the circle, to the same point as the lines from the center of my circle, the angle in the center of the circle will be twice as big as the angle at the edge of the circle, okay? So if we're going to call them x, the angle at the center will be 2x, and the angle at the edge of the circle will be x, okay? So the angle at the center of the circle is twice the angle at the circumference, okay? And when it says subtended by the same arc, it basically means that there's this arc here, and the 2 points are meeting the same place on the circle, okay? But that's a bit of a mouthful. So just for your guys' sake, when you're remembering this rule, the angle at the center of a circle is twice as big as the angle at the edge. Nice and easy, okay? So let's have a look. Let's have a look at this circle theorem in practice then. So like I said before, the circle, the angle, in the center of a circle is always twice as big as the angle at the edge of a circle, okay? So here it is with the numbers. So you can see for the first example, the angle at the edge is 35 degrees. Therefore, the angle at the center will be double that, 70. Or if you want to think of the opposite way around, because the angle at the center is 70, half of that is 35. So that gives you your angle at the edge. And then there's just two more examples. So the edge is 60, therefore the center is 120. And the third one, the center is 170, therefore the edge is 85 degrees, okay? So here's a little visualization of that rule in practice, okay? Because it's a bit unbelievable when you first hear and you try to think of situations where it doesn't work, but hopefully this little diagram, as you can see, the point is moving around the circle. Because these 2 points are the same, the angle as it moves around the circle won't change, okay? So let's have a look at some of the questions you could be asked on this topic. So for example, we could be asked to find the size of angle x when we're given this shape, okay? So they've labeled the x here, which is slightly confusing, but we know that the angle at the center of the circle has to be twice as big as the angle at the edge of the circle. So therefore, x is equal to 2 times 34 degrees. Therefore, 2 times 34 degrees equals 68 degrees. And that's it. That's your final answer. X is 68 degrees because it's double the angle at the edge of the circle. Okay? Let's have a look at another one. We've got another circle here, and we can see the angle at the edge is 58 degrees, and we're trying to find the angle in the center. Again, the angle at the center is twice as big as the angle on the edge. So once again, x is equal to 2 times 58 degrees. Therefore, x is equal to 116 degrees. So if you know the angle on the edge, you have to times it by 2 to get the angle in the center, okay? Another example. Need to find angle x again, but this time we're given the size of the angle at the center of the circle, okay? So we know that this angle is twice as big as the angle on the edge. So therefore, this time x is equal to 164 divided by 2. 164 degrees, sorry. Therefore, x is equal to 82 degrees. Okay, and that's your final answer. One last example. Now, even though we're looking at obtuse angles now, so even though the center angle is obtuse now, bigger than 180 degrees, it doesn't matter. The rule will still apply, okay? So I know that angle x is going to be half of the angle at the center. So x is equal to 224 divided by 2. Therefore, half of 224 is 112 degrees. And that's my final answer for this question as well, okay? So those are the examples. So here comes the main task, or main task 1 for today, or the first part of main task 1 actually. So pause the video and have a think, which of these circles show that the angle at the center of the circle is double the angle at the circumference? Or worded a bit simpler, which of these circles can we use the rule that we've just learned on? Okay, so which of these circles can we use the rule that we've just learned? Okay, so pause the video, see what you think. Okay, so if we look at the first circle, we can see we've got an angle coming from the center point, and we've got an angle at the edge. Okay, so I've got an angle at the center, an angle at the edge. They both meet at the same point of the circle. I'm happy with that. The second circle, now, whilst one angle is on the edge of the circle, the other angle doesn't start at the center of the circle. So unfortunately, I can't use the rule with this circle. The next one, well, I've got an angle on the edge of the circle and I've got an angle in the center, but the points where they meet aren't at the edge of the circle, okay? So unfortunately, we can't use the rule for this circle either. And check the last one now. I've got an angle at the edge, I've got an angle in the center, and they both meet at the edge of the circle. So I can use the rule for this circle, okay? Onto the proper main task now. So here's some questions. Pause the video and have a go at answering them, okay? Best of luck. Okay, so here are the answers. Very well done if you got them all right. Moving on. So this circle theorem actually leads us into another one, okay? So if we consider the circle again, where the angle on the edge is half the size of the angle in the center, or the angle in the center is twice as big as the angle on the edge. Here we've got 35 degrees and 70 degrees. Here we've got 60 degrees and 120 degrees, 85 and 170 degrees, 90 and 180 degrees. Now this is a special quirk of this rule, if you will, because if we notice 90 degrees, there's a name we give to triangles that have a 90-degree angle in them, and that's right angle triangles, okay? So actually, if we know that the angle at the center of the circle is 180 degrees, and we know that there is going to be a 90-degree angle or a right angle in the triangle above it. Well, what's another definition for an angle that has an angle of 180 degrees? Well, that's just a straight line, isn't it? Because all lines have an angle of 180 degrees. So what we've actually got here is when we have a triangle contained within a semicircle, imagine the semicircle around here, as long as one of its sides is the distance of the diameter of the circle and the other side touches a point of the circle, it will always be a right angle triangle, okay? Or to give you a slightly simpler definition, a triangle contained within a semicircle will always be a right angle triangle, as long as one side is the diameter of the circle, okay? And the other point is touching the edge of the circle, okay? So let's have a look at a couple of examples of this then. So here's a little demonstration of visualization of this in action. Because again, when you hear the rule, you find it hard to believe, but hopefully these little visualizations will prove to you that it really is the case, and you're allowed to trust this when you're answering questions. So first of all, so we got a question here. So we need to find the size of angle X in this question, okay? So for this line, we can see that we've got a straight line going across the circle. So this is going to be the diameter of our circle. Therefore, we know that this triangle is a right angle triangle. Okay. And we also know that a right angle is equal to 90 degrees. So if we need to find this missing angle, do we know what the angles in a triangle add up to? Yes, they add up to 180. So all these angles should add up to 180. So let's write down, first of all, so we're trying to find x. So x plus 90, which is the right angle, and plus 58 is equal to 180 degrees. Okay, so collected on this side. So x plus 148, 90 plus 58 is 148. That equals 180 degrees. So therefore, x equals 180 minus 148. So x equals 32 degrees. Okay, and that's it. That's your final answer. So it's just using a bit of triangle angle knowledge. Okay, let's have a look at another example. Again, we're asked to find the size of angle x. So we've got a straight line going across the circle here. We made a triangle with it, so that must mean that this is a right angle triangle. So we've got the same thing again, okay? So we need to find the length of x. We know it's going to be equal to 180 because that's what the angles in a triangle add up to. So x plus 90 plus 17 degrees is equal to 180. X plus 107 equals 180. X is 180, take away 107. Therefore, x equals 73 degrees. Okay, just like that. One more example. Again, I've got a straight line going through the center point of a circle, and I've made a triangle using those points. So I know we've got another right angle triangle here. Just go through the motions. I know the angles have to equal 180. So I've got x plus 90 degrees, which is the right angle, plus 23 degrees, which is the other angle we're given. Therefore, x plus 113 equals 180. X is equal to 180, take away 113. Therefore, x is equal to 67 degrees. And that's the final answer, okay? So here's the main task 2, or a little warm-up for the main task 2. So have a look at these circles and these triangles and think which ones we can apply the rule that we've just learned to, okay? So pause the video and try and think which of these circles can we apply this rule to. So pause the video and have a think. Okay, so if we look at this first circle up on the left here, we've got a line that goes through the center of the circle. So this is our diameter, and we then make a triangle, and the edges meet, the lines meet a point on the edge of the circle. So that means, and there's a right angle opposite the center of the circle. So that means that we can use our newfound rule on this circle. Okay, let's have a look at the next one. I've got a line that is the diameter of the circle, and those 2 points meet on another point at the edge of the circle. The right angle is opposite the center of the circle, so I can use the rule for this one as well. Now this next triangle here, we haven't actually got a line that is the diameter of the circle because we're just shy by a little bit there, okay? So unfortunately, we cannot use the rule on that circle. The same goes for this one. Even though we do have a line going from point to point at the edge of the circle, that isn't going through the center. The line at the bottom is going through the center, but he's just a bit short, okay? So we can't use this circle for the rule either. And the final one, we've got a line going through the center of the circle. Those 2 points meet at another point at the edge of the circle. I'm happy we can use this circle for the rule as well, okay? So let's move on to main task 2 now, the proper one. So here's some questions. Pause the video and have a go at answering these. Best of luck. Okay, so here are the answers. Very well done if you got them right. For question E, you had to use Pythagoras' theorem, okay, because we're dealing with a right angle triangle, okay? So let's have a look at the two checking questions now. So for question A, you need to find the sides of angle BCD. So that means you are trying to find this angle here. So highlight that bit there. And for question B, we're told that if point G is opposite point E on the circle, find the size of angle HEF. So we're trying to find the size of this angle here, okay? So pause the video, have a go with these two questions, okay? Best of luck. Okay, so let's go through the answers. So for question A, we were trying to find the size of angle BCD, okay? And all we were given was at the end of a quadrilateral, so at the end of a four-sided shape here, we were told that one of the angles was 51 degrees. But we were also told that there were two right angles in this quadrilateral shape, okay? And we all know, and we should all know, that the angle of quadrilateral angles is equal to 360 degrees, okay? So that must mean that 51, which is that angle there, plus 90, plus the angle O between B and D, so we'll call that B angle of OD, is equal to 360 degrees, okay? So 51 plus 90 is 231. So 231 plus BOD is equal to 360. Therefore, BOD is equal to 360 minus 231. That means that angle BOD was equal to 229 degrees. Okay? So if we now know that angle 129 degrees, not 229, 129 degrees. So therefore, if this angle is 129 degrees, that means angle BCD is half of angle BOD, okay? Because it's following the rule from the first part of the lesson, okay? So BCD equals 129 degrees divided by 2. Therefore, BCD is equal to 64.5 degrees. Okay, so that's your answer to the first checking question. Very well done if you got that right. Now the answer to the second one, there was a key point you had to note, you had to realize at the start of the question. Okay, so we're told that first of all that point G is opposite point E on the circle. Okay, so that must mean we can draw a circle, we could draw a line, between point E and G, and because they're opposite each other, it will pass through the center of the circle. Okay, now if we remember the second rule, that a triangle formed in a semicircle will always be a right angle triangle. So now we can see we've got two triangles here, so triangle 1, triangle 2, and they will both have right angles in them up there, okay? And if you recognize the shape at the start of the question, it was another quadrilateral, so it was another four-sided shape over here. We've just reminded ourselves that all angles in a quadrilateral add up to 360 degrees. So that must mean that the angle HEF added up to all the other angles has to equal 360 degrees, okay? So let's do that. So we've got angle 32. We'll start the way around. We'll do HEF, which is the angle we're trying to find, plus 32 and plus 90, plus 90 plus 90 is equal to 360 degrees. HEF plus 90 plus 90, 180 plus 32, 212 equals 360. If we take that over, so HEF is equal to 360 minus 212. That means that angle HEF is equal to 148 degrees. And that is your final answer. That is your final answer for the second checking question, 148 degrees. Okay. So very well done if you got those right. Very abstract questions. Have to think about all the rules that you learned in the lesson. And good work, guys. And we're going to continue doing more circle theorems in the next lessons. Okay. Bye now.